Hello, Trailblazer. I am in. I'm at the command prompt, and this is usually where I will start. Just to let you know. It's where I start as a developer. In general. So, one thing. The first thing I will do is I will open up code using code space dot, and that'll open Visual Studio Code. Of course, it opens the wrong window, so why not? I'm gonna close all my. I like to close all my files and then collapse all my folders, and I go back into source. Just gives me a good place to start. So we're gonna create a little bit of model here, but we're also going to create state. We're gonna create a very preliminary state for our application, and then we will populate that state with a model, and we will render that state onto the canvas. So the first thing I want to do is I want to make a change in our canvas component. That's the only component we have in our components folder right now. This onRender function, in order to become state aware, I think it is actually going to have to live within a component. And that's not ideal for reasons I've talked about before, because it's going to have to use a use callback, because we don't want it to be we don't want it to be changing on every render, being a new function on every render. And so we'll do that. So let's actually do that first. Let's take this function out of here, and it's going to give us the red squigglies here, but we'll ignore that for now. And we're going to put it inside here. We're also going to change it to an arrow function. And if you haven't caught on, the reason it's called an arrow function is because that operator right there that I just typed looks kind of like an arrow. It's also called a lambda expression. It's effectively a functional version of a function, which is odd. It's the difference between functional programming and other standards of programming. But it's lambda calculus, which is a big part of programming languages like Haskell. I think it's the main part in Haskell, if I understand that correctly. And we don't want it to do, but we don't want it to do this. We want to use a hook called use callback. And what use callback does is it allows us to wrap our arrow function with a dependency list. And I need to bring that in, pull that in. And if I and there are no dependencies yet, but there will be dependencies in the near future. It'll be the state that we're going to use to render. Right now, it's still rendering our red box. Now, what we want to do is we want to give this render function to our canvas. And so we don't have it on render here. So what we want to do is we want to set up props, but we're using TypeScript. So in order to set up props here, we're going to have to basically create a type for our props. Because if I just go in here and I just do on render, that works for this, but it's going to say, oh, this is any. I'm implicitly considering this any, and we don't like to do that in TypeScript. What you can do, if you really want to, is you can say, okay, sure, this is a type of on render, where we pass context of type canvas, rendering, context 2D, and elapse. That's just what I called it, is elapsed. And that's a number, and this will return void. It's kind of this, and this is a function declaration in TypeScript. Kind of looks like a lambda function, but it's not actually doing anything. So it's just telling you what arguments the function is, and that it returns void. We don't want that to be like that. So this is nice, but it's a little hard to read. So what I usually do is I create a type and I name it. The naming convention I use is I just use the name of the of the component, and just say props at the end, because that's what it's called in React, is props. And so what we're going to do is do on render. We're going to just basically take this from here, take it out of here, put it here, and now we have a type name, and we can use that type name here instead. And the cool thing about that is now on render has type information. That's one of the cool things about, that's one of the benefits about TypeScript, is the compile time. It's compile time checking, but it's also, it gives you type information in places like this where, you know, in JavaScript this would just be a callback and it wouldn't even know that it's a function really. That's why I like Java. That's why I like TypeScript. And so my app.tsx is not liking this because I've added this prop to my canvas, and I've made it required by basically making it, not making it nullable, not making it optional. You make things optional by putting a question mark after them, but that messes with useCanvas because useCanvas doesn't want to get anything with a question mark. And so we'll set that to that, and then we'll go back here, and we will pass our onRender to the onRender property, or the onRender attribute, however you want to think about it. Components are elements. And so I believe, let me spin up my server. That's what rundev does. I mean, it calls rundev, as I've said before, it will call vite, which I guess knows the directory it's being called from, and so gets the data from that, and then launches a local server with the package in that directory. And so that server lives here. And so we've set up our debug to launch against Chrome, to launch against localhost on Chrome, and that launches our red square. Haha. So now what I want to do is I want to create a model. So I'm going to stop this, and I'm going to create a location model, because that's going to be an important part of our, I think it is anyway, an important part of our map, our locations. All these little black dots all over the place are locations. And so location is a big object in our map. And so what we want to do is create a location. And so what I do when I need a model, when I need to create models, is I will add a folder, call it models, and then I'm going to add a file that has a capital location dot ts, not tsx, because it's not going to emit React, but ts. And so here I'm going to create a type, call it location, and it's going to have an x, which is a number, a y, which is a number, because I am going to want to save height. It's not going to be important for rendering the map, but it is going to be important if I say want to teleport somewhere, which probably not going to do in Jordan's realm, but in Doranfall might want to do that. So I do want to have height information there. And then z, which is a number, and name. And we don't necessarily need it to have a name, so I'm going to make it optional, and that's a string. Now we have this here. We need to export it, so I'm going to export it. I'm not going to export it as default, not now anyway. I might later. We export that type, and then we want to create if you're into OOP, you can think of this as kind of like a constructor. It's not part of the type, but it does the same kind of thing. We want to create a create function, and so I'm going to do that. It just makes things a little bit easier, and so I'm going to give it an x, which is a number, a y, which is a number, and a z, which is a number, and then an optional name, which is a string. And so when we just return our x, y, and z, and our name. And that does that. And I guess we do want to say that this returns location, just to give it type, type awareness, I guess. Yeah. Now I'm going to create what's called a type guard. And I'm going to export it because I've been exporting everything. So, and this is spelled wrong. Location. A type guard is basically a way of letting TypeScript know if an object is a location, is a specific type. We're going to say any, and we're going to say location is location. That's the return type. Very complex return type. And so what we do here, all we have to do is verify the properties. So we will check to see. We'll say if x in location and type of location.x equals number. And we'll go one further. Not is non. Because, non is not a number. NaN is not a number. And a value can be a number. Non is considered of type number. So we want to rule that out as well, I guess. Sometimes I do this, sometimes I don't. So we want to negate this because we want to say equals false. And or, because that's the negation of and, does not equal number. Nope, come on, give me. Or it is non, then we return false. And we return true at the end. So I'm going to do this for all the other. So we have y and y and y, and we have z and z and z, and we have if name, if type of name. How do I want to do this? If name, this is a double not, location.name. This is a double not, and I'm going to do an and here because if name is not on here, I don't care. Location could be a location and not have a name as defined above. But if name is on here, I want it to be type of location.name equals string. I want it to be a string. We can return false. So what this is saying is, if there is a name and it's not a string. Oh no, stop. And it's not a string, then we're out of there. No explicit any. Ah, okay. So TypeScript, as it is set up in this case in ESLint, as it's configured here, is complaining because they don't want you to place any type explicitly as any. So they don't really want you to have an implicit any, and they don't want you to have an explicit any. They just don't want you messing with any. But in this one case, any is the only real option. I mean, it's the only thing I'm aware of. Every example of a type guard that I've ever seen uses any. Not really sure what else you'd put here. If you use unknown, you can't access properties off of it. You can't even assume properties are on it. So we are going to, for the purposes of this type guard, turn this off. I honestly don't see any problem with this as long as you know what any is, and if you've been doing JavaScript for a long time, which I have, you definitely know the pain points with any. The biggest one is that it's just not checking. I mean, it's not any. Any is just your default JavaScript type system. It's just your default. It's how TypeScript works. So we're gonna turn that off for the purposes of this. There probably is a way to turn this off just for this, but I don't really want to because I'm going to probably have quite a few of these guards, and I don't want to have to do that every single time. And if I take this out, it's then going to complain that it's implicitly any, and it doesn't like that either. So I guess we'll just leave it in, and we'll have that in our ESLint right there. Our TypeScript ESLint, no explicit any. And let me just clarify that. Let me just show you what you can do here is if you get these and you want to turn them off, first know exactly what you're turning off. If you click on this link, it'll take you to a description of this problem. And you can go there and read about it and make sure that it is something you want to turn off. But if you want to turn it off, you can, copying this is kind of a pain in the butt. But if you go out here beyond the paren and then scroll over, click down and scroll over to copy to select it, and just copy that. And we then just go to our eslint.config and we just add it to our rules. We're adding it as a variable name to our rules. Our rules is an object, and we're adding it as a variable name and a string, and we're turning it off, setting it to the value off. And that will make that little squiggly go away. Okay, so here, one thing I want to add to location, because I know we're going to have multiple locations, and we're going to want to be able to identify locations, and I don't want to identify them by their coordinates, because coordinates change, and if you change coordinates and you try to replace an element within an array, you've lost that element in the array. And so what we want here is an ID, I think. And so I'm going to add an ID to location. I like to use GUIDs because GUIDs are pretty much guaranteed to be unique. They're a long string of letters and numbers, and they're pretty much guaranteed to be unique. And I think it's hexadecimal, but I don't remember. Yeah, I think it's hexadecimal. There have been cases where there have been collisions there because people have been using GUIDs for a very long time, but it's virtually impossible to get a collision there. Think of SHA passers. It's not something that you can really. It's not something that's really going to collide very easily. I mean, that's how Git works. Git works on SHA hashes of files, and if it had collisions, it would totally mess up your repository. So a GUID is pretty much a good thing. In the world of Node, which is what hosts React, you have a tool that I use quite a lot called UUID. I have no idea what that stands for, but we're going to pull that in using npm, our Node package manager. So we do npm I for install, or we can just say install. And we're going to install two things. We're going to install UUID and types, I think. UUID, is that what it's called? Oh, no, what? I don't know what I just did. I'm not sure what's going on. That's weird. I hit tab because instinct. npm install UUID and types. UUID, I think that's what it is. And it'll install that. Node is so much faster now. I love it. See, I would have had to edit that out because it would have been minutes of installing, and now it's lightning fast. I love it. No, and zero vulnerabilities found. Really cool. Really cool. I like Node now. I like npm now. It works really well. So we have that in there, and what that did was it not only did it install the packages, but it would have added these things into our dependencies. This is a TypeScript dependency, so in reality it doesn't need to go here. I'm going to put it down here with my other TypeScript dependencies. It's something that you don't really need in production because you don't really have TypeScript in production. You have it is transpiled into JavaScript by the time it gets to production. So I put all my types down here. This right here just basically gives some type definitions to the UUD functions. And they are functions. They're a suite of functions. So in location, what we're going to do is we're going to import UUID. We're going to import v4 because we like to use version 4 is what I like to use from UUD. going to import that, and we're gonna add to our type. We're gonna add an ID, which is going to be a string. It's going to be required. And here we are just going, when we create this, we're just going to do v4. Simple as butter. Or is it smooth as butter? I don't know. And then down here we need to add if ID in location equals false. Why do I have, how'd that become, wait, what the heck is going on with these? Equals. We need the good equals. Okay. Or type of location dot ID does does not equal string, or location dot ID is basically empty string. Okay, and we're going to return false. Okay, so that is basically done. We have an ID there, and we're adding the ID whenever the location is created. Now we want to, over here, one problem we have with this setup is now we're requiring Canvas to have it on render. I don't really like that. It's just the problem that is that if we change this to optional, then use Canvas has an issue with it. So we're just going to go to use Canvas, and we're going to make this optional, which then the call is going to have an issue with it. And now I'm going to show you something funky. And I say funky because it kind of looks a little ugly. And so I've shown you I believe I've shown you the null conditional operator. So if you have the string, if you have a number timestamp, and you do dot, you can have a bunch of functions on that, but with timestamp is undefined, it's going to throw an exception because you're using the dot operator on it. And then you can do the question mark dot, and then, you know, it will work better. Well, functions have that little thing too for function calls, but it is bizarre because you can't just do the question mark. You have to do the question mark and the dot. And so that is what you do, and it looks bizarre. Shorthand, and it's the one I prefer, and it just looks really strange, but it works. So if this is null, it just won't call it. If it is not null, then it'll call it. So that solves all of our problems. So now we get to create our reducer. So I'm going to go back to our, let's put it in app, because that's where our render function is anyway. We'll just put our reducer here. So I'm going to create two types, because a reducer is a pattern. It's not just part of React. It is a large component within Redux. And if you've used Redux, you will know what I'm talking about with a reducer. A reducer is a pattern, and it's a very good pattern for maintaining and mutating state. Because what a reducer function is a function, it's a function that is idempotent. Idempotent's a fun word. That is a word that means that it is a function that, given a certain state, will always unfailingly return another state. So if you give it state A, it will always return state B. There is a definite mapping, an on-to mapping from one state to the other. And so it's a very dependable thing. It's a very stable thing. And so that's what we're going to do here. And that uses a pure function, which we will call reducer. But right now I want to create some types. And the first type I'm going to create is our state type. And this will be type state. And it's going to have our locations of type location array. That's all it is. The second part of it, like the second part of a reducer, the signature for a reducer is your state and an action. And what an action has a type, which is a string property, and it has a payload, which is the data that the reducer needs to perform the action. And so our action is going to be a little bit, this is going to be a very interesting way of defining a type. And it's TypeScript it's called I think it's unioning types. Oops, action. It's unioning types, and so we have type, and that's going to be add location. I spell it right? Yep. And we have a payload, which is a location. Now, we're going to have more than one type here. So how do we have all of our types within the same reducer? That is where TypeScript gets flexible and fun. So what we can do here is we can union this, and I'm just going to put this in one line so it's a little bit cleaner to read, because it's only going to have two properties, right? We can union this together, and we will do this. And we can say, or type remove, we'll just have a remove location as well, just so to show how this kind of works. Payload location. And another thing that TypeScript has that it's kind of syntactic sugar because it doesn't really mean anything, but it makes these unions look a lot cleaner, is you can start it off with an or. It just looks a little bit nicer. And so now you can pretty easily see that this action can be two things, and it can actually have two different payloads. Like here, I don't necessarily want to give it a full location. I might want to give it just an ID. And so this way I can give it anything that has an ID, and it'll remove that from our locations. So now we get to write the reducer function, the fun bit. So I'm just going to create a function, call it reducer. That was the French spelling of reducer, I think. I can't type recently. I don't know why. So we have state of type state, and we have action of type action. Okay. What we use here in the reducer is a switch statement. And we switch off of action.type. And then we can do case. We have case add location. Thank you, IntelliSense. You're beautiful. And then here I'm just going to return state because we're going to do something. We're going to do something a little bit different here. We have case, return state. And we have case remove location, and we will return state. And a good thing to do here is either have a default or below this switch statement, just return the state. That is the default action for a reducer. Just return the state you were given. Basically change nothing. And so we'll have a default, and we will just return state. So right now, this reducer isn't doing anything. It's just returning state for all three options. But what I like to do is I like to have action functions. It just makes things a little bit cleaner, better organized. And so what this will do here, let's return state from our reducer, just to make that clear. And we're going to say add location. That gets a state of type state. And I'm not going to pass the whole action. I'm going to pass the payload, which is, or let's just say location of type location. And that's the payload. And just pass that in. Right now, I'm just going to return state just to get the squigglies to go away. Well, I don't know. And we will say that this returns state. Okay, function and remove location. We're not going to use this function right now, but it will be useful in the future, and it'll help explain. I'm going to call this location. It's not really a location though; it's just an ID. State. Okay, and we'll return state, just so that we say we're returning it. Okay, so first we'll work with. Let's put. First we're going to put. So first we're going to put our action functions into our reducer. We can just say add location, state, and action dot payload. Perfect. And this is going to be remove location, state, and action dot payload. Beautiful, 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 beautiful. And now from here, we're going to actually do the mutation. Now, here's the tricky bit. The way React works is that it will not re-render a component unless it's using props or hook state that is changed. And it doesn't go into the properties and check properties. So it only checks the reference itself to see if the reference is the same. And by reference, I mean object reference. Every object has a reference. It's a place in memory where it exists. And in JavaScript, you can compare references using the triple equals. So say you have, I don't know, const s is a state. And we'll say create state, I don't know, it's a state and it has locations and all this. And then you can say if s equals state and then do something if they're equal. That's basically what React does. It checks the state, it checks the reference of your object, your state object. It doesn't go into the properties. And so if you have something bound to the locations array, unless the reference of that array changes, it will not re-render the bound component. And that could be a little bit tricky and annoying for first-time developers in React, but it's actually not that bad because there are ways in JavaScript to make that where that makes most sense. In fact, the ways for mutating state in this way, I sometimes do them when I don't need to do them because they're kind of really neat, honestly. Now in Redux, in modern Redux, they use a package called immer. And what immer allows you to do, basically allow you to change state. So actually do something like state.locations.push location, something like that. And then it basically built up this object using, they create a proxy object that records any changes you do. And then it does it the good way with its internal objects, so that React does re-render when the state changes in the appropriate way. So that's what immer is. But here, immer is not in useReducer, and so we kind of have to do it this way. This is a good habit to be in for React as a whole, because this is how React does state management outside of Redux and outside of other package managers that may do things differently. But even in Redux, I think it's a good practice, and I still use it in Redux. And so what we're going to do is we're going to use a lot of parentheses and curly braces. So here we are going to say const location. We are going to destruct out locations from state. And destructuring is good. It doesn't really make much sense with one property, but if you have multiple properties, it's pretty useful to have it all in one line. So if I have paths in here, I can get both of them out at the same time. It's kind of nice. And what this will do is it'll basically get a reference to the locations array within the state. And so here we are going to say locations equals ... locations, comma, location. This is called spreading, the spread operator. Oh, we don't want this to be const. We want it to be let. It's a spread. We're spreading our new location to the end of the locations array. It takes a little bit to get used to, but once you do get used to it, it's pretty nice. And so what this will do is just add our location to the end of this. But I want to make this action a little bit smarter, since we have an ID and we have an ID for location. Kind of want to look into our locations array to see if that location is already there. And if it is there, I want it to replace it. And I want it to keep, we could enforce this with like a set object. I don't know if you can have, but yeah, you can have set in a reducer. I don't know if you can have it in Redux though. Redux is a little picky about what it will store. I don't know. It's married. Redux is married to serialization, even though it stores everything in memory. So I'm not really sure what the deal is there. But anyway, so we want to have an if statement here, and what I'm going to do is I'm going to say const, and I call it found because we're finding, equals locations, not find, and we're going to say I'm just going to say L equal, and then we want to say L.id equals location.id. And so what this is going to do, what is wrong? Oh yeah, this happens to be a lot with with location, because location is, it exists in the lib.dom.d.ts. It's part of JavaScript. In fact, this defines the document.location property. And so it's confusing our location, and this will cause a lot of problems in the future. But I want to keep the name location because I like that name. So what we need to make sure we do in every file where we use location is we want to bring that in. Import location from models. What am I? Oh, where am I? I'm in app, so I want to do models / location. Okay, cool. So, and so we have this location, and it will be a location if it was found. It'll be undefined if it was not found. So we will check if it's truthy, and we'll say if found is truthy. That's basically what that does. We will say we're going to replace it, and replace found with location. We'll do that in a bit. So else, we will add it to the end of our array. And I know people talk about, oh, how dare you have an else in your code. There's so many people that are religiously addicted to flat code, and I am too. I don't like ifs within loops within ifs. I don't like seeing that. It's very hard to read, and it is not very friendly, and that code just begs to be refactored and decomposed. But an else, in a case where you're doing one thing if it's true and another thing if it's false, that's okay, because you're going to, otherwise you're going to have to do something like this, have return state in there, and then when I get rid of that line, whoops. Otherwise you're going to have something like this, where you're returning your state in there, and here you are, I don't know what breakpoint there. You are, and here you are going to return your state after this, and so you're returning state in two different places. And honestly, in my opinion, that's a bigger problem, especially with this, because here we are not just returning state. We are going to again spread. This is spread with us. We're spreading an object here, and so we do ... state, and we're going to spread locations onto that. And so we're going to be doing that in two places. And if this changes in any way, then we have to change it in two places. In my opinion, that's far worse than having an else. I would actually rather have the else. And so we're going to go back to the else. So I'm going to steal this and put it at the end, because we do need that. We do need that spread, because that's how this is going to end. Once we've changed locations, we need to put it back in state, and we're going to use spread to do that. And the cool thing about this is this will change the reference to our state. It'll return a new reference, which will indicate to React that state has changed. And that's always a good thing. You always want to let React know if state changes by changing the reference, if and when it changes. And usually you only want to do that, in a lot of cases you only want to do that when it changes, because that way you can avoid unnecessary re-renders. But that's kind of a performance balancy thing, and you really got to kind of figure that out with like maybe some A/B testing, or just kind of see, don't prematurely optimize and make sure that change happens every single time, because then you'll create performance issues with that. It's a balancing act. Performance is a balancing act, and so you gotta kind of figure it out. And so we're gonna put our else back. Like in this case, I like the else, because the else makes it so they're only returning once, and I prefer that to, oh my gosh, I have an else and it's terrible. It's actually not terrible. It's still kind of flat, because it's just the other side of the if. I don't like having necessarily, it depends on the situation, I guess. I don't like having an if else, else. I would rather have some other kind of construct, maybe a switch statement, but it gets a little bit wacky with that. I mean, I don't know. That's enough of that. And so now we're going to do what we do to replace this. It's actually not that big of a deal. we just do we're going to use map. Map is one of the array functions, and the cool thing about these functions, the map and filter, and there's a few others, they will also give you a new reference for your array, which is beautiful because then you don't have to wrap it in a spread. All you have to do is locations equals locations dot map, and then you have your map function, your callback fun, as they like to call it, and we'll just say L, and then here we're going to say L.id equals location.id, and then we're going to make this a trinary operator because we're going to want to actually return location, not just a Boolean value. And so what we want to do here is if they do equal, we're going to return location. If they don't equal, we're just going to return L. Just like that. Now here, because we have a found location and not just a found index or a found ID, what we can do here is we can actually check reference. Now I don't want to always check reference, but in a case like this, like up here, I wouldn't want to check reference. And when we do a remove location, I wouldn't want to check reference there because here you have an array and you have an external location. And you don't have the information that this location is in by reference in this set of locations. It could be a clone, a copy, of one of these items. It could be anything. And so you, within this context of this add location action function, do not know that the location reference exists within locations. What you do know is that this found, if it is not undefined, has definitely come from this locations array. And so here you can go ahead and check reference. It works fine. It's beautiful. It's pretty efficient. I don't usually have any problems with it, even like a tight array with like lots and lots of elements. I don't usually have a problem checking references in JavaScript. I mean, it's all kind of generally slower that way. But yeah, and it works. It works really well. So here you can check references. I hope you get why I'm saying that it's okay here and it's not so okay here. It's because here you don't know where this location's come from. And so you have no idea if its reference exists in this location. So you want to use the ID, which is a value which probably has not changed. And if it has changed, then it's technically a different location anyway. The ID is a value that we control. Reference is not necessarily a value that we control, if that makes any sense. I hope I clarified that, but that is why it's okay here and it's not okay there. Here in our remove, we're going to pull locations out. It's going to get mad at me for using let because we are not yet changing locations, and it's going to say, well, you shouldn't use yet unless you're changing locations. And that's an important thing, actually, I want to talk about, because here it's complaining about us using let, and that's because in reality, let is not the replacement for var. Let is, hear me out here, let is not the replacement for var. In a real way, both const and let are replacements for var, but const is the default. Let should only be used if you're going to change the reference of your variable. Again, let me be very clear here, because this is a thing that a lot of people in our industry get very confused about. Let should only be used if you are in this function, in this code, in this scope, going to change the reference for locations, which we are going to do here. That's why I'm using let. Everywhere else, you use const. People are going to complain about having to go back and changing a let to a const, but if they do, you can complain about why the heck they're mutating your reference, they're changing your references when you clearly don't want them to. No, I'm kidding, but you can make a stink like that though. But yes, you should use const unless you need to change the reference, not mutate. If you can mutate a function, you can mutate a thing even if it is const. Like I can go in here and I can say, let's see, what's found. I can say found.y equals -13. Why is it not liking that? Oh yeah, because it doesn't know if it's, so if found is not, you can do that. You can actually mutate constant objects. Const has nothing to do with mutation of the object. Const has to do with whether or not you are changing the reference. It is all about clarity on that reference. And there's things in the C language, there's things in all sorts of different languages that have this. JavaScript until now, until const and let were created, did not have that. And the creator of const thinks it's terrible that he named that variable const. He says he should have come up with another name, but he just called it const, and now everyone thinks it's a constant. It's not really a constant, not in the traditional language way. It just means that you cannot change the reference. This will always be the same reference within this scope. If you send it out of the scope, if you return it or pass it into a function, all games are off. But within this scope, it is within the scope, and anything that closures within the scope, it is the reference cannot be changed. And so we do want this reference changed. So that's why we were saying we're putting let on our locations. And so, man, my voice here. The way we want to do this, we don't need an if statement, because if it doesn't exist, we just return the location as is. We're not going to return. We're not going to do anything if we can't find the item. We're not going to do anything special to the state. And that's something else that's important here. Is these functions, this reducer function, should not do anything that it's not directed to do. So in this case, in this remove action case, if we don't find the location, we don't do anything. We don't return anything. We don't do anything about that. We just do not remove the location. That's all that's all that this reducer is asked to do. So the way we're going to do this is we use map up above and we use find. We're going to use filter now, which is an array function, and we're going to say locations equals locations.filter, and here we're going to pass a predicate, and a predicate returns true and false. And the way filter works is it basically keeps all of the items for which the predicate returns true for that item. And so in this case, we want to keep everything that doesn't have the ID of the location that we're given. Or it's not really a location, it's just an ID. It's an object with an ID property. But we want to basically say, so we're going to say L.ID does not equal location.id. Some people get that backwards. Some people get that mixed up. And that what happens then is that locations becomes only the item you're trying to delete. And that can be a headache. So don't do that. Make sure that your logic is sound. And you can, one thing, I don't know that we're going to do very many unit tests, at least not in this initial project. I do like unit testing. I do it as much as I can. But one thing you should probably do in this case is maybe create some unit tests. That's one thing that the reducer pattern is wonderful with, is unit tests, because it doesn't have any side effects. There's nothing to mock, quite literally nothing to mock. And you just pass it in a given state and an action, and you test the state you get back to be what you want it to be. And so, yeah, it's pretty easy to wrap unit tests around this. I'm not gonna, like I said, I'm not gonna do that because it's kind of the out of the scope of this first project. But yes, I like doing unit tests, especially on things like this, especially when you want to make sure that it's changing your state in the way you want it to change. Okay, so moving on from here, let's see, what do we want to do now? So now we're going to hook this reducer up to our app component. We're just going to put it in the app component for now. It may not remain there, but we're going to put it there now. So what we do to hook up a reducer to React is all we have to do is const, and this will return an array. And we want to say use reducer, and the reducer will take our reducer function. And the other thing that it takes is an initial state, and I want to set that up here. So we're going to const initial state of type state equals, and we're going to give it locations, and we're going to give it an empty array. Simple as that. So our initial state will be empty, and we're just going to give it an initial state here. And the other cool thing about this initial state and this reducer is that just using the properties alone defines it. So you can see up here, it defines it as a reducer that takes a state of R type state, an action of R type action, and returns state of R type state. And yeah, the initial state is so it sets. That's another cool thing about React. I mean, other languages do this. C# does this too, to some extent, but it just makes it really readable, so that you don't have like a reducer type inside your generics list. And so this returns two things. It will return your state, and it will return what's called a dispatcher or dispatch. Dispatch is a function. It's a function that you pass actions into. And the function doesn't return anything, but it'll change the state. This will change, and then app will re-render. This works very much like useState. I don't know if I covered useState in this project yet. I might have, but I don't remember. But useState returns a value and then a setter for that value. And if you pass a new value into that setter, then the state changes, and the component the component that has that hook re-renders. This is the same thing, although this dispatch doesn't take new values. It takes actions to mutate the value, and the state is just, it is what it is. It's the state. It's this object with this locations array. And so what we're going to do now is we're going to render that state to in our render function. And remember what I said before. In order to do this, we want to put this in our dependencies. So we're going to put state in there, and we are going to basically render our locations. I'm just going to render them as ellipses. And we'll do for const location of, if you do in, it's going to return you indexes, not actual locations. So remember of, because there's also in state.locations, but this is just going to return you indexes. It's not going to return you actual locations. So you'd have to do, let's say, just call it L for now, and you'd have to do something like const location equals state.locations of L. And you'd have to do something like that. It gets a little, but if you do of, I get tripped up by this a lot. Like, I forget of all the time. But if you do of, then it will actually return you the object, the element within the array, not the index. And the other things, the in could be good because you want the index. And so what we're going to do in here is we are going to draw the location. We're going to draw it as a little ellipse at the x and y location that it's at. It's actually the X and Z location because, reasons. So we're just going to make little black circles. So we're going to do context dot fill style. That's what we had with our I should keep that in there. Hang on. Let me bring that back. Bring our little red rectangle back so we can compare. Okay. So I'm going to put this back here. Our fill style is going to be black. See, our fill style up there was red. Now, we don't have a little handy dandy fill. It's got to be an ellipse because in programming, a circle is just a specialized version of an ellipse, and that's okay. But we don't have a fill ellipse, so we're going to have to create a path, and that's fine. It's not hard to do. We have to do begin path. And then at the end of this, after we've drawn our ellipse, we're going to do context fill. Some people get confused with this. Some people just do the ellipse function, and they're like, why is it not drawing my ellipse? And it's because the ellipse function is adding an ellipse to your path. And that can be very confusing for people, but yeah. And so ellipse location dot x location dot z, and then we want an ellipse has two radii. It has a major and a minor radius, but these are both going to be 10 because we're drawing a circle. And then we don't want to rotate it, And we want the start angle and end angle to be the same, but unfortunately, in order to do that in this case, we have to start it at 0, and then we have to wrap all the way around to 2 pi. So we do math.pi times 2. This is in radians, that's why we're using pi and not 360 degrees. You could easily create a function to convert from degrees to radians if you want to, but most drawing programs and stuff like this, they prefer using radians over degrees. And so we have that, and we're filling. And so what that will do is it will begin our path, basically open up the space for a path. It'll fill that path with an ellipse, and you could even do 2 ellipses in this path if you want to. You can do a whole bunch of operations in this path, and it won't actually render it until you call fill. And we're going to get rid of our red square. And also another thing I want to do is, I think it's useful if the canvas does the clear rect itself, at least in this case. Like I said, you can do that thing where you keep the past and you just render on top of it if you want to do something funky looking or something like that. And so what we're going to do is go in canvas, and we are going to it's in use canvas. We're going to go into use canvas, and in our step function right before we call render, we're just going to do that, and we're just going to clear the rect there so that the render function is given a clear rectangle every single time. So we're going to go back here. We're taking in the state and we are rendering out the locations. That is the output. Now we want to do something with the dispatch side, because if I run this now, where am I getting the, it's the dispatch. Yeah. If I spin this up now, it's pretty much going to be useless. So let's go ahead and try it. So if I spin this up right now, it's not going to do anything. It's just going to sit there. It's just going to be an empty canvas. That's nice and everything, but it doesn't really do anything. So we're going to want a way of actually calling dispatch to actually add locations. And this is not how this is ultimately going to be done, because we're going to have a more user-friendly way of adding locations and paths and all of that stuff. But for just demonstrating the power of this code, I am going to add an event handler on pointer down. I like pointer down because it's mobile friendly. I will say that the use case for this app is not mobile and probably won't work very well on mobile, but I like to use pointer down just because it's a good habit, because it works. It's a superset of mouse down. It does everything mouse down does, but it has other functionality for pointers and stuff. And so if I'm moving over to something like React Native, or if I'm writing a browser app that I do want to work in smartphone land, then I have the tools at hand. So I do tend to use this. So I do tend to use pointer down and pointer up and pointer move. I don't think there's a double click for pointer, but I think you can pull that concept out of the event somehow. And so I'm just going to do an event, and this is going to be react.pointer event. And if you want to specify that it's the canvas, you can do HTML canvas element as a generic, but we really don't care. It's fine if it's just an HTML element. And then we are going to dispatch. We're going to call the dispatch function from up above. And so we're going to give it a type. I think, oh yeah, I've got to make an object. We're going to make an object, and we're going to give it a type. And it should be, yeah, if I put the quotes, it gives us our IntelliSense and in Visual Studio Code gives us our options for what this can be. I'm going to do add location and payload. Create location. This is where we're going to be creating the location, at least in this case. And we're going to do event dot client X. We're going to do 0 event dot client Y. And I'm not going to give it a name right now. And then we have to pull in create location from our model. And that should have brought it in the same. Yep. This is why I didn't want to make location default, because it just puts it all in one little set of brackets. It's just kind of nice. Little bit cleaner in a way. Now we can't just attach this to canvas because it's not an element, it's a component. And so I'm going to go to the components, We're just going to add our little on pointer down. We'll make it optional because it is optional by default. It is optional in the element anyway. And we're going to say event, and it's react.pointer event, and it returns void because most events do. And then we're going to say on pointer down equals, and we have to actually put it in the here. All right, and on pointer down for on pointer down. So that will pass it to the actual canvas, and we will get called. Oh, I have to actually plug it in here. On pointer down equals on pointer down. Beautiful. Okay, so as far as I know, this should work. Honestly, this should just work. I may have a bug somewhere. Nope, nope, beautiful, beautiful, beautiful. Click anywhere, and your location just gets added. It's very nice. So this is it. This is, well, there's a little bit cleanup work we have to do, but you can see that you click there, and it adds a location. And if I go into our use canvas, no, it's not use canvas. Where is it? It's app, isn't it? Our render function here, and you can see in state. Well, that's fun. I wonder if, oh, darn it. I know what's going on. Yeah, now it's 5. Now it's 6. This is not what we want. So we are compounding this. That's fun. Why are we compounding this? I think that maybe... So I'm going to change this up here. Yeah, so the reason that was happening with the weirdness there is I think that the handle needs to be updated every time that request animation frame gets called. And so we're going to just put the handle up here as a let. And it's, what is this? What type is this? Is an integer, isn't it? Yeah, I mean a number. Yeah, just put number equals 0. And we are going to basically just do that. And then in here, we're just going to do handle equals that. I'm going to restart this, and we're going to see if that weirdness still happens. And I'll put my... Oh, yeah, got to take that breakpoint out. I'll put my... Okay, and I'll put... Let's see. And I will put my dots in, a whole bunch of dots, whole bunch of dots, whole bunch of dots. And I think that when I put my thing in here, it should just give me one with, let's say, 24 dots. And if I hit run, it should always just be 24 dots, and that fixes that. Cool. Cool. Yeah, these bugs are, they crop in every once in a while. You forget things, you leave things out. But if you find them, they work. And this issue, it wouldn't have been a problem until you had like hundreds and hundreds of elements, and then it would basically just be running your render cycle way more often than it should be with a whole lot of different data. You'd probably get a little bit of flicker, maybe. I don't know. There's a whole bunch of things that could possibly happen with that. So it is a good idea to kind of figure out that, test and see if your render is actually rendering once and only once per render cycle. And you could see we have 24, and I'm not going to count them, but I'm pretty sure that looks like about 24 dots. And so it's just rendering through them, and it's getting the state from our reducer and our little pointer, which is what gets clicked when you actually click the thing. Okay. When you actually click it, you get them here, and you get your client X, your client Y, and you do this. And then if I go up here into our reducer function, it'll call the reducer function, and it should be type add at location, which goes into here and does all the magic in here that we saw. It's going to add a new location because we're not actually editing a location. Yeah, and then it returns our new state object with our new locations object. And yeah, so there we go. One thing I want to do here, is that in our app, you have a lot of code in here that doesn't really have to do with the app component per se. It's more part of the reducer. So I kind of want to move that out of here. And I'm going to do that by basically adding, I want to add a folder. I'm going to call it state. And I'm going to add a class. And I'm just going to call it reducer because that's the name of the function. And it's going to be lowercase reducer. I want to actually add it to the state folder. Reducer.ts. And this is reducer. This is lowercase reducer because the name of the primary function in this class is going to be reducer. These aren't going to be exported unless we want to do some sort of unit testing on them. So it's not it's not really about that. I am going to export state and action from this, but again, this is just basically the reducer file. I might actually separate state into its own model, action maybe into its own model, although action is more coupled to the reducer function than state. State is a little bit less coupled because it's the actual state object itself. I don't need location anymore here, and I'm going to move this into reducer. All right, and we're going to have to pull in location because again, it's thinking that location is our document.location object, which it is not. And so what we're going to do, no, I don't want to do that. Come on. So what we're going to do, go up here and just import location from models.location. And there's that. What's up? Why is it not liking this? Oh, it's capital L. That's why. Yep. Node is very Linux friendly, and Linux uses paths that are case sensitive, and so that's where you get this has to be capitalized to match the name of the file. And the reason we capitalize this location file, is that the type itself is capitalized. And the same thing with our components. The reason why I capitalize canvas, the naming convention has us capitalize this because components are capitalized. In fact, they kind of have to be capitalized in many ways. The JSX doesn't work unless your component object is capitalized. You can't have lowercase. You can have lowercase elements, but you can't have lowercase components in your JSX. So we have to pull in some things here. We have to pull in, not emit. Why? Oh, I haven't I haven't actually exported these yet. You can't pull something in that you haven't exported. So we're going to export again. We're not going to have an export default here. That's okay though. I have export defaults on components. I have export defaults if something is pretty much the only thing that you're going to export from a file. But if there's a lot of things you're going to export from a file, I don't usually use default. Sometimes I do. It really depends on it's just basically an expert position and decision. So I'm just going to bring that in from reducer. I have to bring our reducer function in from reducer, and then that clears up everything. I'm going to pull my CSS file to the bottom. Let's see. So yeah, that should still work. And we have refactored all of that stuff into its own file. It's looking very nice and pretty over here in reducer.ts. Again, these are not exported because this is only means anything within this. It's only used by the reducer. I just have them separated out to make it a little cleaner, and you can see more easily the separate functions. Another thing you can do is define these functions on an object with these as the property names, and just check to see if this type exists as a property on that object, and then call that function if it does, and then you can just have this as a simple if statement and a call. That's a little bit nicer. That's nice too. I think it gets a little bit iffy with the TypeScript stuff, but it's something you can figure out. And yeah, so that's that. I think that's where we're going to end it. Okay, so one thing we're going to do, and we should probably do this every time, is we're going to go to our console, and we're going to say, and you should do this after you make any moderate size change, just so that your Git history is concise and to the point, and it's easy to back up if you need to back up, and you shouldn't have enormous commits. I wouldn't say this is an enormous commit. It's only 8 items that have changed. That's about the size of all the commits we're going to do. And you should always space out your commits and get into the habit of, committing responsibly, I guess you could say. So what we're going to do is we're going to do git add dot, and I am going to git branch. Oh, yeah, let's commit this to main, and then we'll create a video2 branch. So I will do git commit, and we will call this, let me see what I called the other one, git log. Yeah, we'll call it video2. Git commit message is video2, and I will push that. And another way you can either create a video to branch and then switch to it, or if you want to use the old style checkout, you can do something like git checkout with a B flag. This will basically create video2 and then check it out, switch to it, and there you go. I don't think switch has the B flag. I haven't tried it yet though, and we're going to push that. I always do that. Origin video2, bam, and it should push that up to GitHub, and that should be available on GitHub now. All right, cool. So this is what we've done for now, and we will continue on in the next video. Thanks.